All right, so check it out, guys. Notes 6, graphing cosine and sine. And notice I still didn't put any sine graphs, but we'll do one of the one of the sines together in a little bit. Real quick, just make a note. This is what we've been doing lately. This is what we know how to do right now. We haven't really messed with sine yet, but we will in a little bit. Some textbooks write the argument as bx plus c, relax. If you want to see the shift, you got to factor out that b. I think we're pretty good with graphing. Notice that now the x-axis doesn't have degrees, so that means we are in radian mode. The only thing that changes is the b. In the past, when we were in degree mode, we said that b was 360 divided by the period. Because we're in radian mode, we're no longer going to say 360. What do you think we're going to say? No, not 180. That's still degrees. 2 pi. 2 pi is equivalent to 360 degrees. So we're going to say 2 pi over period is how you get the b. Remember, the b is just really your horizontal stretch or compress. We will get into that when we do a free response questions from you'll see. It's not that bad. It's the same concept from your algebra days. What's up, Miss White? Yeah, that's exactly what we're going to do on letter example 1 because that's exactly what they asked for. So it says, find a particular equation for the sinusoid function graph below. Notice the x-axis doesn't have degrees, so it must be in radians. So we're going to do this. We're going to go y equals a cosine b x minus c close plus d. The a is the amplitude. Your b really is your horizontal stretch or compress. So the b is defined as 2 pi divided by the period. The period should have been 2 pi. That's for your parent function cosine. The c is called your phase shift. Just a fancy word for horizontal shift. And the d is called your midline. Sometimes also called sinusoidal axis. Are we okay? Nothing crazy, right? Okay. Remember, side note, I guess I'll do a side note here in green. Side note that the cosine graph, y equals cosine x, looks like this. So it has a peak right on the y-axis. Are we okay? All right, let's figure out stuff. Chav, what are we going to figure out? I see my y scale is by 1, and it looks like 1, 2, 3, 4, 5, 6, 7. Yep, it looks like your x scale is also by 1. Let's see, what are we going to do? Let's find the midline first. My low is a 1, and 2, 3, 4, 5. My high is a 5. What's in the middle between 1 and 5? What's in the middle? Right? What's the number right in the middle between 1 and 5? 3. So 1, 2, 3. Notice, yep, that definitely looks like a midline. Half the amplitude is above, half the amplitude is below. Maybe I didn't word it right, but yeah. Yeah, the number right in the middle between 1 and 5 is 3. Cool or not cool? Nothing crazy, right? Nothing crazy. Okay, next in line is your amplitude. The amplitude is this gap, the distance from the high to the midline, or the distance from the midline to the low, the difference. So you can either say 5 minus 3, which is 2, or you can say 3 minus 1, which is also 2. Both of them are the same. Are we okay? Perfect. We got the A, we got the amplitude, we got the midline. So now we need two things. We need the B. So we get the B by doing 2 pi divided by the period. So I'm going to come here to the side. I'm going to write the period is, let's see, I have a peak right at 1. And this peak right here is at 11. You don't have to do peak to peak. You can choose other methods like min to min. I have a peak here at 1. I have a peak here at 11. So I'm going to go 11 minus 1. What's that? Yeah, say it again. 10. So the period's 10. So B equals 2 pi divided by 10. Reduce that sucker to pi over 5. Are we okay so far, guys? Nothing crazy, right? All right, let's see. What's next? I need the phase shift, the C. The C, I see that I have a peak because I'm using cosine. That peak should have been on the y-axis, but it's no longer on the y-axis. It is 1 to the right. So 1 to the right. You could have also said 11 to the right, but we'll talk about that when we talk about transformations. Do we got everything we need? All right, here we go. You're going to go y equals, the amplitude is 2, so write 2. Cosine, open parenthesis, pi over 5, open parenthesis again. X minus 1, close it twice, plus 3. What am I going to do next? I'm going to check it. That's the number one issue that you guys have had. Some of you guys could have had better scores on your assignment, but you didn't check. Check it with your calculator. So I'm going to make sure I'm in radian mode. How do you do that? Click on mode and go down. Make sure that radian is highlighted or else your answers are going to be wacky. Go to y equals and type in this expression, 2 cosine alpha y equals to get the little fraction. I guess you don't necessarily need to be fancy like this, but I want to put it in there. Pi over 5. I think it was 5. Open parenthesis again. X minus 1, close it twice, plus 3. Does everyone have that? Yes, miss. You push alpha, and then you push the y equals button, and then you have these options. Push the number 1. Just push enter, and you get the little fraction. Alpha is right next to the x, or right below the second button. I haven't graphed yet, guys. I haven't done anything yet. All right. Does everyone have that equation in there for... Okay. Here we go. Click on window. Let's see. What is my smallest value? I see -1, so I'm going to put -1. For x max, let's see. I go all the way 10, 11, 12, 13, 14, 15, 16, 17, 18. I'm going to put like 20. X scale by 1, that's fine. Y minimum. It looks like it's -1 here in my little scale here. -1. Y max. They go all the way 5, 6, 7. I'm looking at the grid here. You don't have to go all the way to 7, but I'd like to see. You can go higher if you want. Y scale, leave it alone. Leave X resolution, delta X, and trace step alone. Push graph. And I'm just going to check. I'm just going to check that it works. I'm going to push the trace button. I'm going to push the number 1. I'm going to push enter. And check it out. At 1, I in fact do have a high of 5. What else am I going to check? I'm going to check 1, 2, 3, 4, 5. I'm going to check at 6 that I have a low of 1 there. So trace, or I can just push 6 here. Enter. Yep, I'm at 1. I push 11. Push enter. And I'm back at 5. I have a max of 5, low of 1. Do we see how we did it, guys? Cool or not cool? All right. Let's go to the next one. We're not going to do... Oh, yeah, the next one. Oh, Chav, we've never done one with a pi in there. Okay, it's the same. We're going to sketch. I'm going to go really slow. Really slow. Find the period, amplitude, phase displacement, and sinusoidal axis location. Use these features to sketch a graph. Okay? I'm going to write the word period. I don't know what that is. I come back to the side, and I remember, well, if b is 2 pi over period, that must mean that the period must be 2 pi over b. Just a little algebra, right? Times period, divide by b, 2 pi over b. Are we okay, guys? Okay, well, the b, they tell me that the b is 2. So I'm going to go period must be 2 pi over 2. OMG, the 2's cancel out. The period must be pi. Job, we've never done one with a period of pi before. Well, we're about to do one right now. Are we okay? Nothing crazy, right? What's the amplitude? What is it? Yeah, 5. Let's see, we got the period, we got the amplitude, phase displacement. I'm using cosine. So because I'm using cosine, your phase displacement is what? Not pi, but pi over 4. Pi over 4 to the right, because we're using cosine. Using cosine. So peak moves pi over 4 to the right. That's for comments. I'm trying to make good notes here. That's a parenthesis. It doesn't say cussing, in case it looks like a C. Are we okay? Okay. Here we go. We got the phase displacement. Sinusoidal axis. It means the same thing as midline. Sinusoidal axis equals, what's the sinusoidal axis? Yeah, not everyone at the same time. It's 8. I wonder if like my fans, I mean, I don't know, I call them YouTube people. I wonder when they hear my videos or see my videos, I wonder if they think I'm talking to myself, because I don't think the mic can pick you guys up. So I'm like, yeah, that's right. And like, no, why is this guy talking to himself? Okay. I can assure you that I'm doing this live with a live audience. Okay. What's up, Miss White?
I'm wondering how you changed the period.
I didn't change the period. Ask me though. I found the period.
But I don't know. Why wouldn't we just use the period they gave us?
They gave me the period of pi. The 2 is not a period. The 2 is just the b, your horizontal stretch or compress. You get the period by doing 2 pi divided by period. The parent function has a period of 2 pi. That 2 really means that I am compressing I'm compressing the period by a factor of half. So the period should have been 2 pi, and 2 pi times half is pi. That's from your Algebra 1 days. We found the period. They didn't give me the period. That 2 is the b, your horizontal stretch or compress. Does that make sense, miss? Yeah. Give me more questions, guys. I want you to. All right, I need your A game, so let's focus right here, because this is going to be the big deal here. All right, this is the first time we've ever done this with Radians, guys. So I need your A game. I'm gonna do a sketch. I'm going to exaggerate quadrant 1. So here it is: y-axis, x-axis. Everyone do that. Where is the midline? Yes, that's right. Oh, well, that's where I'm going. I see the midline is 8. I go 5 above. I go 5 below. I never go below the x-axis. Yeah, I know. You're getting ahead. That's fine. I know, because the midline is 8, and I'm going 5 above and 5 below. Where's my midline, guys? So go to 8. You can be anywhere. I'm going to say that 8 is right here. And go. What's my amplitude? 5. So I'm going to go 5 above 8. So what's 8 plus 5? So I'm going to say this is 13. And what's 8 minus 5? I'm going to say this is 3 right here. Not to scale, in case someone's measuring with a ruler to see that my scale is correct. So I'm going to say not to scale, NTS. So do you see how I found that I knew that I was going to be in quadrant 1, Miss White? I mean, I guess technically it also goes to quadrant 2, but I'm just going to be focusing on everything to the right of the y-axis, since I make a power 4 to the right, and then I'm just going to keep going to the right. Okay. Is everyone here right now? All right, so check it out. You can choose the grid however you want. So I'm going to choose to put my pi over 4. See, it says, remember, at pi over 4, you have a peak for cosine. I'm going to choose to put the pi over 4 right here. Pi over 4, and I'm going to put a point at the 13. Chav, how do you know that? Because remember, I'm using cosine. Cosine has a peak right on the y-axis, and I move that peak pi over 4 to the right. Are we okay? Okay, I know that this repeats every, what was the period? 1 what? No, you're right. 1 what? 1 pi. It repeats every 1 pi. Yes or no? All right, so then I'm just going to add, look, I'm just going to go to here to the side, and I'm going to write what's pi over 4 plus pi. Relax, it's really simple to find this. Chav, how do you do it? I can't do it. Just put 4 over 4. 4 pi over 4 is 1 pi. Whatever the denominator is, make it 4 over 4, see? So what's 4 pi plus pi? I'm going to say that this right, yeah, you said it right, 5 pi. I'm going to say that this number is 5 pi over 4. At 5 pi over 4, I put a point at the max. Do you guys see how I did it? I'm going to keep going. I'm going to try to make it equidistant. I'm trying to make my little, so I'm going to say this guy right here is, what's 5 pi plus 4? 9 pi. Make sure to put the denominator of 4. I'm going to keep going. What's 9 pi plus 4 again? So 13 pi over 4. I'm going to do one more because I think I can fit one more. 13 pi plus 4. 17 pi. How do we feel? At all those points, you have maximums. Chav, why? It repeats every pi, every 1 pi. It repeats every 1 pi. Yay or nay? Okay. In between the two maximums, you have a minimum. So right smack in the middle between pi over 4 and 5 pi over 4, you put a minimum. Chav, I want to know where that is. Okay. Go pi over 4 plus, what's half a pi? Oh, I guess I just said it. Pi over 2, that's half a pi. Get a common denominator, times 2 over 2, so 2 pi over 4. Do you guys see how we're doing it? What's 2 pi plus pi? Another one at the same time. 3 pi over 4. Check it out. 3 is right smack in the middle between 1 and 5. And I keep adding pi. I just care about these two right here. 4, 5, 6, 7. 7 pi over 4. 7 pi over 4 is right smack in the middle between 5 pi over 4 and 9 pi over 4. See? So, boop, another minimum right there. Another minimum right here. I don't like this minimum here. Let me go right there. All right, I think we look good. We almost got it. Between the max and the min, I have a point of inflection, and that point of inflection, all right, focus, happens on the midline. So let me repeat that again. Between the max and the min, I have a point of inflection, and that point of inflection happens on the midline. So between pi over 4 and 3 pi over 4, I have a point right smack right there. Take a guess. What's in the middle between 1 and 3? 2. So this is 2 pi over 4, and I want you guys to make a note. 2 pi over 4 is the same as pi over 2. You could have also kept on going by adding quarters, right? You know that 25% is going to be pi over 4 because you knew, okay, let me slow down. So guys, don't write anything down, just listen right now so you can take this in. The period is pi. The period is pi. Remember, we do it, that's 100%. So 25% of pi is literally pi over 4. If I were to go pi over 4, like let's say I wanted to know where this midpoint is. Pi over 4 plus pi over 4, look, you get that 2 pi over 4, which is right there. And 2 pi over 4 obviously reduces to pi over 2. Do you guys see how we're doing this? See? Okay, I just want to make sure that you guys understand that. Between the min and the max, you have another point of inflection. Boom. Where is this one at? This one is at 4 pi over 4, which is the same thing as just pi. Those are the only ones I care about. I mean, I care about all of them, but those are the ones I'm going to check. All right, the rest, just eye it out. Don't have to be perfect. Bam, right on the midline. Bam, right there. Boom. Boom. Like Chavez says. Boom. Boom. There you go. Wherever you have a max, upside down bowl. Dr. George, if you're viewing this, sorry if I'm calling it wrong. I don't think she'd use my videos, but just in case. Wherever you have a min, put a bowl. and then connect them to the midline, to the points of inflection. Not my best work, but it looks okay. We're not trying to be super accurate here. And look at you guys. You guys just did a wave. Let's verify this. And look how beautiful all that looks. Let's verify this. Type this into your calculator. 5 cosine 2. So let me see. Calculator, y equals. I'm going to clear both of them. 5 cosine 2, open parenthesis, x minus alpha y equals, enter, pi over 4. I guess you don't need to be fancy like this or Gucci like this. Close it twice. What was it? Plus 8. I think it was plus 8. Was it? Plus 8, yeah. Does yours look like that? Okay. Make sure it's a minus and not a negative. X minus. So use this one, the next one to number 6. The pi is where the caret symbol's at, but you got to push the blue button on top of the division sign. This is called a caret in programming. Okay, we're ready? All right, here we go. Push window. X min. I don't really care what happens to the left of the y-axis. X max. Okay, here we go. On X max, relax. It says I go all the way to 17 pi over 4. So I'm going to take my calculator and I'm going to type 17 pi, like so, divided by 4. Enter. It's going to turn into a decimal. That is fine. My decimal is 13.35. Did you guys get that? Okay. X scale, you can put pi in there. 3.14. Yes.
What is scale?
Scale just means all these little hash marks. On mine, there were pi over 4 away. I'm just putting them pi away. Y min. Y min, I'm going to say 0. Y max, I'm going to say 15 or 16. 16. And then Y scale, that's fine, 1. Push graph. I actually want to see the midline. I'm going to go back to Y equals. I'm going to go to Y2 and I'm going to put 8. You don't have to do this. I just want to see it because I'm going to test it right now. All right, here we go. Here's the test. So you can make sure that you always get it right. Push the trace button. I know that I have a max at pi over 4. So I'm going to insert pi over 4 like this. Push enter. And you don't want it to say 12.999 or 13.001. You want it to just say 13. And it does. Next, what am I going to test? I'm going to test the midpoint, the midline, to make sure that I have a point of inflection. So I'm going to test pi over 2. So I'm going to push pi over 2. Second, pi over 2. Enter. And yep, I'm right at the midline. 8. Next, I'm going to test the low. I should have a low at 3 pi over 4. So I'm going to put 3 pi over 4. 3 pi over 4. Enter. And yep, I have one there at 3. Do you guys see how we did it? Okay. All right, guys. We just got one more thing to do. Take your activity out. Don't worry. You already know. Don't worry, we're almost done, guys. We're just going to do one more together as a group, and then we'll set you loose. You already know how to graph sine. You just don't know that you know how to graph sine. Okay, I need everyone's attention for this one. On cosine, remember it was the peak that we were looking at? For sine, so write this down, but not yet. I want you guys to focus real quick. For y equals sine x, this is what we're going to be focused on. So it goes right through the origin. Do you guys see that? How it goes right through the origin? We're going to focus we're we're going to focus our attention on that point. It's a point of inflection with the graph increasing. It's a point of inflection with the graph increasing. So we're going to focus our attention on that point. Instead of a peak, we're going to focus our attention on a point of inflection with the graph increasing. Yay or nay? Okay, so check it out. You already know how to do it. So I'm going to do number 1 for everyone. Is that okay with you guys? Okay. What is the amplitude of number 1? 4. What is the phase shift? So what is my C? 2 to the right. But I'm going to make a little comment. Point of inflection, graph increasing. And I'm going to put another parenthesis, using sine. Close and then close. Don't worry, we're gonna show you the picture. And then let's see, the midline is 5, and then this pi over 3 is gonna help me get my period. I don't know if you guys can see it, but the period is 6, but if you don't see it, it's okay. Look, b equals 2 pi, b, period, let me start again. Period equals 2 pi divided by b. The b is pi over 3. 2 pi divided by pi over 3. And now let me slow down because I know I'm going fast. Okay, check it out, Miss White. You ready? I am going to do keep, change, flip. Keep the 2 pi. Change the division to multiply. Flip the pi over 3. The pi's cancel out and I get 6. Some of you, maybe once you have more experience, you'll be able to figure out that you could have just gone it from here. Multiply this by 2 over 2. There's my 2 pi over 6. Oh, there's my period. But if you're not there yet, don't worry. You need more experience. Just like in life. In life, as you get older, you get more experience, and that's why you get more knowledgeable about stuff. Okay. Are we okay? I haven't done anything yet, guys. All I've done was just get the A, B, C, D. That's all I've done. I haven't done anything yet. You guys ready? I'm going to do a grid. Again, check it out, Miss White. I am in quadrant 1 because that midline is 5, and I'm going to go above 4 and below 4. Do we see that? So I'm going to exaggerate quadrant 1. Let me see. Where do I have the most room? Right here. The midline is at 5. So I'm going to say 5 is right here. I'm going to go up 4. So I'm going to say up 4 is like right here. That's 9. I'm going to go down 4. So I'm going to be like right here. I'm going to say that's 1. Are we okay? Nothing crazy, right? Everyone catch up to here. Cool or not cool? All right, so check it out. Let's think a little bit. It doesn't require much thinking, just a little bit, guys. So check it out. Think a little bit. My shift is 2, but notice it's not a cosine, it's a sine. So I'm shifting this graph right here that you're seeing right here. I'm shifting this 2. So I'm going to say that 2 is like right here. Where do I put the point? Do I put the point at 2.1, at 2.5, or at 2.9? Look at this graph right here. Do I put it at 2.1, 2.5, or 2.9? Do I put it at 1, 5, or 9? At 1. So I have a few people that are saying at 1 down here. Is it a min? Is it a midline? Do I put a point at the minimum, a max, or in the middle? In the middle. Why? Yeah, guys, look. The y equals sine x goes right through the origin. The max on the sine x is a 1. The min on the negative sine x is a negative 1. It goes right through the origin. So this point, if I'm shifting it 2 to the right and it's a sine graph, it's going to go right through the midline, going up like that. Do you guys see that? Because it's a sine graph. Okay, what's the period of this graph? So I'm going to go 6 to the right of 2. So that means at 8. So go to 8. I'm going to say that 8 is right here. And again, you're right smack in the midline, but it's going up again. So sometimes you guys put going down, make sure put a little tangent line going up like that. Don't worry, in a little bit we'll fix it. What's 8 plus 6? So I'm going to put 14. And again, midline going up because it's sine graph. Are we still okay? What's 14 plus 6? So I think this is enough. 20. Point going up. And I'll wait. Do you have those points like that? All right. Right smack in the middle between your 2 points of inflection going up. So let me see if I can continue this graph down here. So don't write this down, just listen. I tried to write it. Check it out. This one right here is another one going up. Do you guys see that on the parent function, sine x? So right smack in the middle, I have another point of inflection, but it's going what? Down. So between 2 and 8, put 1 in the middle, a midline again, going down. That one's going to be at 2, 3, 4, 5. 5. Halfway between 2 and 8. Again, right between 8 and 14, put 1 in the middle. That one's going to be 8, 9, 10, 11. That one's going to be 11, going down. Excuse me. The curve is going down. The curve is decreasing at that moment. You'll see it right now once we sketch it all. Go between 14 and 20, going down. Cool or not cool? All right. Well, check it out. Look how awesome this is. You see those 2 points of inflection, one going up, one going down? Right smack in the middle between those two is a maximum, a peak. Perfect. So that one happens at 3.5. All I'm doing is cutting the period into quarters. The period was 6. Half the period is 3. A quarter of the period is 1.5. 2 plus 1.5 is 3.5. Do you guys see how I'm doing it? I'll say it again one more time. The period is 6. Half the period is 3. A quarter of the period is 1.5. So 2 plus 1.5 is 3.5. 5 plus 1.5 is 6.5. So at 6.5, I have a minimum. See? Now the rest, just wing it. Just look at it and wing it. Wherever you have a max, make it approach your midline. Wherever you have a min, make them approach your midline like so. Stretch them out towards your points of inflection. And then connect them. All right. Lowry, ask me what you were asking me earlier. Oh, yeah, that's a good question. Because you see how this one's a sine? The sine function starts like this. It starts at the origin. Or it goes through the origin. I don't want to say start because it goes forever, right? It goes through the origin. And because this says x minus 2, the origin point, this point right there, is what you're moving. You're moving this point right here 2 to the right. So when I move it to the right, it looks like that now. Of course, you're doing a vertical shift as well, right? That's why it doesn't go through the x-axis. But it's this middle point that you're moving to the right. So it's like if you were to be able to drag, if you were to be able to drag this point to the right, it would go like that. So all I did was I dragged it to the right. And of course, that 5 means 5 up. So that's why I go right there.
No, yeah, but like I get the like points and then like each 6, but how do you get the ones that like go back
Oh,
down?
because it's right smack in the middle. Between here and here, those are going up, right? And look, right smack in the middle is one going down.
So you just put it
In between, here's one going up, here's another one going up, right smack in the middle. So what's between 2 and 8? The 5. Ooh, what's up? Cosine, the peak is right on the y-axis. So that's why we always use the peak for cosine. Does that make sense? Ask me, Liberty. Liberty. Sorry, miss. I had to. Ask me, Lib. Okay, so you're good. You're gold. Platinum. Okay, I'll stop. Let's check it. You have a calculator, let's check it. I'm gonna plug this in for sine. So we're so close, guys. We're so close. Y equals top left. Hopefully you're getting really beast with your calculator. for sine alpha y equals, enter, second pi over, was it 3? And then let's move to the right. I'm going to open a parenthesis. What was it? X minus 2? Yeah. X minus 2. Close, close. Plus 5. This time I care about the midline. So I'm going to put a 5 on y2. And I'll wait for you guys to catch up. Did you guys bring fries for the ketchup? Tough crowd, tough crowd. Okay. Are we all here? Does everyone have this? I put the y2 equals 5 because I want to see the midline. You don't have to if you don't want to. Click on window. Let's see. Y min. Well, I guess I don't care here, so I'm going to say 0. So 0. Y max. Let's see. I go all the way to 20. So I'm going to say 20. Y scale, X scale by 1. Did I say Y max? X min, X max, 0, 20. X scale 1. Sorry, guys, about that. Y min, I'm going to say 0. And then Y max, I'm going to say 11. You can say 10, but I want to go a little bit higher. And then Y scale by 1, that's fine. I'm going to push graph. And you already know. I'm going to push trace. I'm going to check which one first. I'm going to check the 2 one first. So I'm going to push 2, enter. And yep, I'm right at the midline. That's where I should be. I'm going to check the max next. I know that I have a max at 3.5. So I'm going to put 3.5. I'm going to push enter. Yep, I have a max at 3.5. I'm going to push, let's see, what am I going to push? I'm going to push 5. I better be decreasing at 5. It should be in the middle, in the midline, but decreasing. And yep, there it is, point of inflection with the graph decreasing. And then finally, 6.5. So I'm going to put 6.5. And there I am, a low of 1. It works. How do we feel? All right, guys, I prefer this activity today, but you can turn it in tomorrow. But work as a group. You guys have all your members in full force. Give it a shot. And yeah, and ask me if you have questions. I'm here. All right, let's get this done, guys. Let's get this done.